So this is just returning back to my experiment, or not experiment, my model, where I'm predicting the level of virulence displayed by, in this case, bacteriophages. Virulence being the equivalent of latent period, where longer latent periods, longer times over which the phage is infecting, equivalent to less virulence, and shorter times equivalent to more virulence. And the prediction of the model is that these phages will essentially display faster population growth when they have the shorter, more virulent latent periods, so long as host densities are higher, so long as host availability is higher. It pays to initiate your infection and make as many progeny as you can as fast as you can, and then get them out there to acquire new hosts to infect, if in fact hosts are highly available. If hosts, however, are not highly available, which is seen at the left side of the x-axis here, the left side of the figure, then you have an expectation that less virulent individuals will come to dominate the population. And the reason for this is that when you're less virulent, you have a longer latent period. You can produce more progeny, just like the microcolonies that are displaying a higher yield, and therefore those progeny, when they're released, are able to find with fairly high likelihood the very rare hosts that are out there. So low probability of finding hosts, or low probability of finding surfaces to colonize, can have the potential of selecting for higher yielders that display lower virulence in this case, and higher host availability has the potential for selecting for lower yielders, but nonetheless individuals that are more expedient and therefore more virulent against their hosts.